Hello, my very extremely wonderfully magnificent good friends. We today here are going to explore electronics, atomic particles, and everything. However, don't freak out. We are going to go into, there's only going to be a few minutes of the geeky stuff, and then we're going to go into how to use a meter and how little motors work, and we're even going to talk about gravity and electricity and static electricity, all that stuff, and you're going to find out things that you're going to be able to use. I'm going to tell you about wire, different types of wires and how they work and why you have shielding and coaxial cables and all kinds of stuff. You know, I like this stuff. This was my realm. So, and we're going to get into electronics and the nature of the atom, because it has been proven now that it's not correct. The Bohr model has been proven wrong, and we're going to go through a lot of stuff. It's going to be fun. All right, this is going to be outstanding, and you are going to learn a ton from here. Now, what are we looking at here? The new boson appears in nuclear decay. It breaks the standard model. Bohr model is destroyed. Forget about it. It's history. Now, what replaces it? Here it is right here, the electron flood theory. There's nothing more than electrons. Entire universe is nothing more than flooded with electrons. It works very, very nicely in this chart when you start to understand that there's 1,837 of them make a proton, 1,830 of them, 1,838 make a neutron. And this is the way, and I'll get into this quite deeply. Now, and I'm also going to show you that with this motor right here, this little tiny motor, I am going to be able to explain to you what gravity is, how it works, and how our magnetic field works. Stay tuned. I guarantee you will understand that. If you don't understand that, I don't know how I can help you. I absolutely guarantee when I am done, you will understand how gravity and our magnetic field works. Okay, my friends, now let's talk about gravity and the particles that are in space. Now, we know that light is light, and we get light from the sun. I mean, obviously, we get light from the sun. There's particles coming to us from the sun. Now, this is the moon overlaid on the sun during a solar eclipse. So, what do we see? We see the actual interaction of the sun. It's way, way out there. But the moon, you know, and this was written about, I think, somewhere in the past, that it covers the sun, and it does. It covers the sun almost exactly from our perspective on Earth. Now, what is all this? Well, I know what it is. The sun is spinning, just like we're spinning. And as it spins, its most impact is on its sides. It's spin just like ours is, the equator and so forth. That's where all our heat is. Now, what is this? These are the polar regions. What's this shooting out and shooting out this way? Why is this all gluey and gubbly and all that stuff? Well, this is scrubbing through a whole bunch of other stuff and spitting out, because it's scrubbing through stuff just like we are. It's identical to what we are doing, the sun is doing. Only the sun is becoming extremely upset at scrubbing through that stuff and spitting out a ton of particles. But it also has a south and a north pole. A south and a north pole, just like us. This is our gravitational field. If this was the Earth spinning through space as it is, as the sun is, as all the other planets are, they all have magnetic fields. It's scrubbing. What's scrubbing? Well, our atmosphere is out here. Right? Our atmosphere is pretty much glued to our planet. Now, it boils around a little bit. That's the source of different weather patterns. That's why the weather patterns flow and this and that. Now, why do they change? Why do the weather patterns change? Oh, obviously they have to be changing because something's hitting us different every now and then, to my way of thinking. Now, so I'm not thinking that we're having a consistent flow against an exact same pattern of particles every day, day after day. Maybe we are, maybe we're not. But I can tell you what, the sometimes a region will flow down, sometimes it'll flow this way. Let's just forget about that for now, but let's just keep it in the back of our minds. Now, we have a pole on each end, and the right-hand rule, when you spin through particles, and everywhere there is particles, all the same particles as in our air, they're electrons. When you spin through them, it creates a magnetic field that spins to the right. Now, that drags electrons up through the pole and out the top, back around and this way. However, it also drags them down in here because they're flowing through. So the entire sphere, the electrons are flowing in to this flow, which is the polar flow. Simple as that. That's gravity. Now, how much gravity do you get? Why do some things hit harder than other things? It's strictly related to the number of electrons in the size of the plus and minus package. Now, when all you have is electrons with lightning, static, electricity, they just right to Earth. There's nothing stopping them. And when they hit, they explode the particles that they hit. If you ever see when lightning or static hits something, or anything that's 100% electrons, which those things are, it's going to explode the things that it hits. Literally explodes them. Now, a little static, well, it doesn't kill you or anything, but you could feel it. And it's my point is there's nothing to stop. It instantly slams. Now, hydrogen and helium, they don't have enough electrons in that confined space to come. They're not being pulled. They drift out. As you get higher and higher in the periodic chart, they get heavier and heavier. That's just the way it works. There's more particles glued together in the mass, and because more particles per square inch, let's put it that way, more electrons, and because everything's an electron, so the more you have per section of space, the more harder it hits. And we know that. We can feel that. You pick something up, it's light, that it's not crushed in with electrons or particles of whatever nature you think they are. I say they're electrons. If it's heavy as hell, that there's not much extra space inside this thing. It's packed. Simple as that. Now, what about gravity? I said I could prove it, and here it is right here. And I can prove that Earth is a generator. So let's watch what I have to show you. Now, this is just a little tiny electric motor. And what this does, this is the kind of motor that has a little, what they call an armature in here. And that has brushes. And those brushes touch the commutator. Now, that commutator has wiring through there. And as it spins, it goes, it hits these fields. Now, we send electricity in there, and it polarizes the field, and it pulls, I'm sorry, yeah, it polarizes the field in the armature, and it pushes itself away from one of these stationary magnets. All right, there's magnets in here. Well, there's two big magnets one on each side, and as this armature, which has wiring in it, I'll show you what an armature looks like. Let me show you, make more sense. All right, here's what we're looking at, an electric motor. Well, what is an electric motor? There's a couple different styles, but this one here is this style right here. All right? It has what they call a commutator. Right? And there's brushes. So the brushes, and as it goes, you see there's little bars of copper. Each bar runs to one of these little coils. So you polarize a coil, the next one goes to the next one, as these bars go and hit the next brush, the brushes stay stationary. This spins, and the bars hit it. I'm here, I'm here, I'm here, I'm here, I'm here. And as it goes, it polarizes like a magnet. And what that does is that magnet pushes away from another magnet, which is in the body of that stator. Okay, the stator is the frame that this thing spins inside of. This is called the, armature is what I call it. Commutator, they call it. Well, the commutator is this part of it. The whole thing is an armature. And the frame is the stator. Yeah, see armature right there. Now, the magnet out here is just stationary, it doesn't move. But this magnet goes bloop, 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 and around in a circle. So it pushes away from this magnet. That's what gives it its torque. It push, 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 push. And they're, of course, they're around in both sides. And these are going to be really, really powerful. So when that magnet kicks on, it pushes very hard away from that magnet. And then the next one comes, the next one comes, the next one comes. Simple as that. That's how a motor works. Now, what else could a motor do? Well, a motor could actually generate electricity. And you say, well, how could that happen, Roger? Well, all you have to do is, instead of running the electricity in, you turn the shaft. So you're just doing exactly what the electricity runs in, it makes a shaft turn. All you got to do is turn the shaft and electricity goes out. It's as simple as that. Now, and I prove it. It's easy, very easy to prove. Watch. There's my meter. Can you see that already? All right, there's the motor. Now I got it hooked up to that. Now if I put electricity in, obviously the motor's going to run. If I spin the motor, will I get electricity out? Yes, I do. Look at that. See that? See that? So that's how they generate electricity from windmills and water and all that business. That's how it does it. It forces a motor to run backwards. Simple as that. So what does that tell you about our magnetic field of our Earth? It tells me that the magnetic field of the Earth is generated because all of those particles from the sun, which are particles, they're negative particles, they're electrons, they're in space, they're floating out there, and we're swooshing through them. And as we do, we're spinning through them just like I'm spinning this, creating this electricity. That electricity flows around and through the poles and sucks electrons into the body of the Earth. That is gravity. That's why if you went to a place that had more and more and more dense particles on the face of the Earth, or on the face of that planet, it would pull particles harder and harder down, because it's strictly magnetism. Now, we do have an issue though. We're overloaded with particles right now. We've overcharged our planet, and it's us causing electrons to be emitted from particles that have captured them and held them. They call it CO2, they're worried about the CO2 as a blanketing and not letting the radiation back out of the Earth. That has nothing to do with it. The CO2, when you burn it, it's liberating huge balls of electrons that were normally all in a box. They were all together. So they weren't pushing anybody out of the way, because everything is, the only thing that causes heat is push. You're pushing electrons against other electrons. That's what heat is. And cold is just so many electrons, extra ones, just walking their way back out. That's what cold is. One of them will accept them, and one of them will push them out of there. That's the flow of heat and cold. And superconductivity is nothing more than having no extra electrons whatsoever. Cold is when you have removed every single electron. Right? Because heat is just a pile of extra electrons. Right? Cold is just the opposite. It's no extra electrons. There's none whatsoever. Because otherwise they'd be pushing and creating heat. So there's none whatsoever. So now you have a condition where it wants to take, give me all the electrons you can give me, I'll take them. I will superconduct with those babies when they go through there. It's just as simple as that. And when something overheats, it burns up because it cannot continue to flow those particles. Too many. That's what heat is. Okay, my friends, once again, get your answer here, not here. Now, why do I say that? Well, what are they talking about? Something mysterious is going on at the sun. In defiance of all logic, the atmosphere gets much, much hotter the farther it stretches from the sun's blazing surface. Well, the sun's surface is 6,000 degrees. When you get out to where the corona is, it's millions of degrees. Why? That's the part that's scrubbing through space. It's scrubbing through all the other particles. How could this not be understood? The problem is that Einstein said that there is nothing in space, there's a vacuum, there's nothing. Well, we know that's nonsense. We know that everything's coming to us from space, from the sun, the heat, and you go outside, you get sunburn. Obviously, you're getting hit by something. Now, the atmosphere is here traveling with the Earth pretty much. You know, it's going a couple of miles an hour, but we're spinning pretty fast, the Earth is. Now, so we're spinning through all of this stuff, and at the same time, we're all moving through the arm of the Milky Way. So this is being scrubbed and spinning twice this much, you know. Now, what space are we going through? I don't have any idea. We're going through whatever's in front of us. It might be exactly the same every day, or it might be different tomorrow. But I can tell you one thing, as this thing scrubs through that space, the more it scrubs, the more generation it creates. The more generation it creates, I showed you with the little motor, the more electrons are going to be accumulated on the Earth. They will be absorbed by the Earth. They will be absorbed by the soils and the waters and the air and the trees and the cars and the houses, and everything will absorb it. And then it'll get to a point where you're at the limit of absorption. Now, I don't know when that happens, but I don't think it's too far. So what we are doing now, every time you burn anything, all right, you take these particles, and these are in a ball like that, 10 billion trillion of them. When you burn it up, you got 10 billion trillion balls this big around, taking up everybody else's space. That's what heat is. So that's why we're overheated. And that's why we need to get rid of the combustion things. We need to be able to use possibly fusion. And the Venturi that I was showing you with that light, well, if I showed you, but that Venturi has a possibility of creating fusible parts. And what I mean by that is a heavy particle comes through that explodes into charge separation, which means the bits and pieces are apart. They have to come back together. You saw the whites come back to the black. Well, when it comes back, it would hopefully, if they're these big particles, they are going to come back to their most stable state, which is helium, instead of heavy hydrogens. Then you have left over electrons, bazillions of them. And you can do whatever you want with those. You can turn them into heat or light or you know, their energy. So we got to do something. If we could do anything, then we got to do something. Okay, don't forget electron flood theory. I think I showed you that. I did already, or I will soon. This is just recent, a couple of months ago. New boson appears in nuclear decay, and it breaks a standard model. It's been broken a long time. They finally just admitted it, and they also admitted it at the university. Royal Academy or whatever it is, a big institution in London that it was Mendeleev and all these guys came from. Now, it's wrong. The Bohr model's wrong. So what do you do from there? You have to go to the entire, start over again. You absolutely have to start over again, and that is it right there. All you have to do is remove all of the nonsense and say it's always made from electrons. Everything is made from electrons. So let's take this a step further. Okay, here we have BrusPup, and this is Amazing Resonance Experiment. Now what they have is a table here, and they're going to put salt on there. And then they're going to run a frequency generator under there, which is nothing more than this. They put the salt on there, and then they're going to run this frequency generator, a tone generator. Now, what it's going to do is it's going to lock in these. They say they become more complex. Yes, the higher the frequency, which means the more resonance vibration, it will take those same particles and turn them into not just what they were before. It'll make them more elegant and more elegant and more elegant. And it's every time they increase this. Now, I see the rule of 8, and this almost looks like it's atomic particles to me, manifesting in front of us. Now, is that possible? I don't know. But it's the higher they go, the more complex it gets. Let's just go way out here and see how complex it does get. All right? I mean, they just get more and more and more complex. So, now let me show you the electron flood theory and quantum. Okay, you should be able to follow this, and you should be able to know quantum mechanics within a matter of the next couple of minutes. Remember I said we have electron flood. I think I told you this. That means that the center, the black spot, is where your positives, which don't have any, they don't explode, they don't do anything. They'll all group together. They don't want to push apart from each other. They don't care about being together or not. The red ones will not stay together. But they have to be attached somehow to the black ones. So they'll all keep as far away from each other as they can and force all the black ones more or less into the center, giving you this cloud of negativeness on the outside. So more electrons want to come in to the positive attraction, because these are the ones, the red ones are the ones that they push and shove. They can pull and push. Now, the black ones, they don't care. They just float around with the red ones. And when the red ones concuss and go explode like a bomb, the black ones just fall off. They don't care. So the red ones will collect around the outside and force more red ones away because they're trying to get in. Of course, the black just rides with it. But this way here, that's how we end up with a positive center and negative out here, keeping all the incoming negatives out. And he's going to do it right here. This is Bruspup. I'm sorry, this is Latham's Crazy Machines. The other one was Bruspup, the rule of 8 vibration. Now, watch this. What he's doing is he's got the positive core, he's got the negatives around it, and then he's going to have his electrons come in and try to get in, and they can't get in. All right, watch. Boom, and they'll stay there forever. And what it will do is it depends on what the configuration of the core is. Now, I don't know if the cores become stable and they don't jiggle around at all, and I imagine they do. And if that's the case, and we saw those stabilities form, that will stay right between a certain vector, or whatever you want to call it. It's going to be something that's going to trap it inside of its magnetic potentials, one side to the other, and then this one will push the next guy out here, and that one will push these guys out, and they'll form round rings, because some of them have a lot of electrons surrounding the center, and you only can have 2 right up close, and then it goes into the rule of 8 as they go out further and further away. All right, let me just explain something to you. Everything there is made of electrons. There are no neutrons and protons. That is a collection of these particles, and there's a zillion of them in each one of what they consider to be a proton or a neutron. Now, in electron flood theory, every electron makes up everything. That's all there is electrons. You can separate the positive from the negative. And one of them is extremely explosive, and one of them has just got only enough power to carry this one. It's a carrier. This one has 1 electron volt, that one has 1 electron volt. A positive and a negative. They add together. But when they slam into something, this one goes into orbit. And this one just stays at 1 volt. It doesn't do anything. It's like a dead sack of meat. It blip, drops to the side. And that one explodes like a bomb. So you have your strong force and you have your weak force. And that's what's in an electron. I will show you that in light. Because light comes out like that. And when it crashes into something, the red, well, it's actually a white and a black, can separate. And when they separate, that's charge separation. And that's, I don't think it's ever been seen before. I'll show you what I'm talking about in a minute. But this is 4 electrons, you see? There's actually, this is what it would look like in 3 dimensions. You got this, but then you got the backside of it. So you got electron, electron, and then the backside electron, electron. All right? So that's what a 4-banger of that looks like. That's a photon. This is a 1 electron of an electron. Now, these float around in the air. They think there's no extra electrons in there. There's a zillion of them. And they're attached to water molecules. So when there is water molecules in the air, there's just a ton of extra electrons. Now, when those water molecules evaporate and go away, there's still a ton of extra electrons. Well, what happens? They collect on you. How? Static. And why do they collect on you? Well, you have rubber shoes on, so they can't just migrate through you to the ground. So they collect on your body. So you're walking around and they say, ooh, there's a guy who's got a bunch of water on him. Let's go glue to him. So they do. Because there's nothing else, there's no water in the air. It's just very dry days. You know what happens. Dry days, you get static, a snapping. What's coming off of you when you see that snap? That snap is 100% electrons. 100%. 100%. And the same thing is lightning. Comes right down to the earth. Same thing as electricity. All electrons. They're extra. They're called ether. All right? Plato knew this. They all knew this. It's called ether. And ether exists everywhere. And I'm going to show you it exists around our globe and is the source of our magnetic field. And it is the reason we have gravity. Okay, now don't forget, we got a ton of extra electrons. We just have to understand that. They just float everywhere. Now, and that's all there is electrons. So when they talk about the number of protons and neutrons, and that works very well for these elements, and these are the stable elements, and in between is isotopes and unstable elements, and the way they have it characterized with protons and neutrons works very well. And this 1837 and 1838, however, of electrons make these. They are not big chunks on their own. Just remember that. They flood into the core, and then they build a chunk like this for hydrogen, and its outside layer is the negative layer, forcing the positive layer in. Then additional electrons will not penetrate. They'll be kept in their orbitals, and then the more dense the nucleus is, the more electrons will try to still get in, because the more positive attraction in the internal part, and anyway, they'll just form a nice symmetrical cloud around her, which has been seen, by the way, I believe. As far as I know, they can see some of these. Well, these are the pictures they claim of electrons in their orbitals and so forth. Now, let's go a little further. All right, I just want to be sure you understand the particles that we're scrubbing through in space, and the sun is scrubbing through in space, is the dark energy and the dark matter that they've been looking for. It's everywhere. It's all the particles of light. I mean, it's just everywhere. So we scrub through them the same as the sun does. Our surface is 80 to 90 degrees on the surface. Out here in the ionosphere and the magnetosphere, it's thousands of degrees. Here, it's 6,000 degrees on the surface of the sun. At the corona, it's millions of degrees, because that is the point of impact. That's the point of rub. That's the point of scrub. They're particles pushing against each other, electron to electron. Whenever that happens, you get yourself heat. And this is the way the light comes off. There's different frequencies of light, faster, smaller, bigger particles, smaller particles. The moon only emits this little bitty particle. These come down, zip, zip. This one comes zip, but it's only re-radiated particles, so you can't get the same colors. Anyway, I don't know what else I can say about it. Alright, that is pulsed red laser. From just a very simple construction laser, just like this. Pulsed red laser. Now, there's only a dot in there. There's only like a particle, and I will show you this and prove it to you. Alright, there's that pulsed red laser, and look at, there's that particle. And it is escaping because it's accelerating. You can see, there's no question, it is accelerating. Now, why is it accelerating? Well, here's why. Because of this, which is a venturi. And the way that venturi was constructed was two round metal drums, one right here and one right here with a tiny slit between them. And because there's roundness, forced everything to concuss into itself. Those particles are coming through here. They don't want to be in each other's face. Well, once they hit here, they can't get through here quick enough, and they just explode. They just bomb out. Now, I told you the white is totally different than the black. The black just falls away. The white explodes like a bomb, and let's look at that. All right, now don't forget, I said that's basically the structure of photons, which are light. And here they are. Now, what are we seeing there? Coming out of here is the accelerator. They come out blurry and kind of excited, and then they step down and show themselves this way. And that happens for a couple, like two, and it's always only two, and then it goes into something else. It sort of steps out of that energy range. Now, let's look at that energy range itself. All right, I don't want to get this too crazy now, but here's the accelerator over here. Now, the green ones come out way further than the red ones, and I've got other shots I can show you about that. But here's the same sort of thing, only obviously they're green instead of red. And green just means a more powerful impact. Now, here's where you can see red and green together coming through the same orifice. So, there's a lot of difference to the power between red and green. I know everything I'm saying sounds like the guy's got to be insane to be talking like this. It's more than what CERN is doing, really. These are electrons. These are in the electron range. CERN is using gigantic particles, like they're basketballs, exploding in all kinds of chunks of this and that. We're using already the smallest particles that exist, light. So when we shoot that electron high speed, it's coming out high-speed electrons. When it goes through the venturi, you can see it accelerating. I don't care what anybody says. It's accelerating. That means that electron, which is, light is electrons, photons, call them what you will, but they are the things that are the smallest particles. They crash into, on the other side of the venturi, into this. Now, wherever these are coming from, they might be coming from outer space, I don't know, and they are going to crash, but ours crash after the venturi. So let's say the venturi is right here, bam, they come out of here just flying. That is what they look for. They call them electron neutrino, electron showers. I'm not making up the names, I'm not making up anything. It's exactly what they say, and exactly what they say they're looking for. And it's exactly what Rodney produced with his experiment. Not only that, these are our Higgs fields. And something very interesting. This is all red laser. This is all red laser. How did that happen? Well, I know how that happened. I think I know. Is that these are all red lasers. Poof, 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 and these are the spinning polar particles. These are as well. However, this one got crushed on both sides, and And instead of the field being able to splay itself out nice and freely and spin forward, it's crushed in here. So it's and that's when you get this higher frequency energy emitted and more power. That's just power as hell compared to these. And then it's stepping down again. It's squirted out like a cork. That's all I can see from here. Now, I could be wrong, but that's what I'm taking away from this. That red laser can turn into blue laser, blue light in that particular situation. So maybe we could have a second Venturi or something, turn red into blue. I don't know. I have no clue. But that's what I'm seeing. All right, this is stuff from CERN. Now, these are gigantic bombs. Thousands, tens of thousands of particles more than what we're working with. And then they explode into all this debris. Now, they still make the same circle patterns because it's the same particles. They're just bigger chunks. That's all it is. Now, I worked with Rod Warren for well over a year. I have literally hundreds of pictures of light. And now these are the ether particles I'm talking about. All these little light dots. They're extra particles that are in the air, and they concuss and glow when other particles come and try to invade their space. Even the ones way out here, they glow because everything's being concussed. The whole thing is being perturbed. And when they come out, these are the kind of fields you get. Now, this one here, that's a particle nobody's ever seen before. I can guarantee you that. I don't know what that is. It's smaller than light. Now, that is what I consider to be the photons. This shows light spinning to the right, which would mean it would drift to the left, and it is compressing at the top of there, which obviously means it's slowing down. It's wide here, and it's getting flatter and flatter, closer and closer. Light speeds up, slows down, it's a particle. A lot of things need to be looked at. Alright, you saw I'm coming through the Venturi. Remember, this is a big round thing here and a big round thing here. Well, each one of these particles owns a region like this big. I mean, literally huge. And when they come here, they crush. Now, the black ones, remember I told you the black ones just walk away. The black ones just back themselves right out. And the black ones can glob into little balls together. See them over here? Every one of them is a little dot. And each one of them was attached to one of those particles here. When they came here, and the explosive ones are exploding. And the black ones just backed off and just are floating around. And then they're going to come and reassemble over here. But during the plasma phase, they're gone. They nothing here. That's why I say we can charge separate. We can make this into 100% negative. It looks like to me. And the black ones, see black, 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 black. They black, 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 black everywhere. They just back out. They just get away. They say, ooh, do what you're going to do. We'll come back later. And they do. And they don't mind being all globbed together. That's why my electron flood theory, hold on, that's why this works. This is what really drove me crazy. Because if you're going to have particles that have a positive and a negative end to them, and really that's what it is, like this, a positive and a negative end, because the blacks don't mind being right up close to each other, the black particles, they're going to be the ones that are going to force to the center. The other ones are going to try to get away from each other. They're going to sort of hang around each other, not tight, and keep the black ones facing in. I would assume. That's what I'm thinking of. And it changes the whole nature of the nucleus. I mean, well, it has to change because it was wrong. And here they are right here, backing off, and then coming back. No black here whatsoever. That is charge separation in my world. And if we could do that, that means if you did this with heavy particles, the big hydrogens, you might be able to cause fusion from this. And this is a totally passive device. This is absolutely no extra. You just shine a laser, boop, it's done. And then on the other side, all he was using, Rod, was a cell phone. Hold on, I got one right here, the same one. Here it is. And it has to be apparently this cell phone. All right, because there's something to do with the selfie feature of this cell phone picking up the correct frequencies. Rod did the work on this. I am not that skilled in that. I understand it, I think, but he is the one that did the actual experiments, and he absolutely unbelievable amount of work he must have done. I mean, you just couldn't even imagine. Anyway, I mean, I'm seeing things that I can't dismiss. I can't dismiss these things, and nobody can. They can only ignore them. You can only ignore that. I'll show you a couple other of Rod's stuff. Look at this. That's coming at us from the Venturi, and as far as I'm concerned, that is the particle. And it's what it does is it spins in its own little position, but as it spins, because it has a magnetic field to it, it has the little thing is spinning around like this. So all of these that are surrounding it, the ether that's in the air, they start to circle around it as it passes them. That's what I'm seeing. And you see them, these are little, you see the little circles? Those are almost identical to this. Watch this. I'm telling you, man. This thing's pretty well shot now, but where do you see these little circles of black with the white around them? Yeah. The black with the white around them. That's what happens. That's the fields. What can I say? All right, and I suppose I'll leave it with this. But this is what the particles do. They come spinning like this. Well, this is a single slit. So you have your Venturis here, and it's coming through spinning like this. Well, sometimes it spins that way, and if it comes the other side, comes under, it spins over here. And you can see how this is high and this is high. There's nothing down here, nothing here. It's spinning behind, and the same here. It's spinning behind, and it falls behind. That's what you got. You got to spin, and because you see these here, those are not repulsed. They call it interference patterns, and this is only single slit, so there's no interference to flap this, because it's usually a double slit, and it'll do it with a single slit. They just have ignored this, and it's not, nobody can deny it. They just have ignored anything that doesn't fit the scheme. They just ignore it. It's terrible. So what happens is this spins this way that time, and as it comes over here, it spins this way that time. Right? So sometimes it's spinning way over here, or here, or here, or here. So they come this way. And as they come through, they're pushing each other apart because of repulsion. Let's look at that. You see that? That's repulsion. Here they have become so embroiled with each other. Don't forget now, the particle is so small you can't see it. It owns an enormous region. It's called a 21 centimeter rule. Look it up. A 21 centimeter line, I think they call it. Now, so they're just fighting each other like crazy and forcing to squirt through here just like it does a hose. Extremely high powered coming through. And then they start to settle down at about this distance right here. This would be called an abrupt transition. I use them in my other work. Now, but then you see these, what they would call interference patterns. They're not interference patterns. What they are is the particles will start to set up a row of particles, and that'll push all the other ones away. These are going to be pushed away from these. So it'll set up another row, another row, another row, another row. Just the way it works. Nothing to do with overlapping interference. And again, all of these little bitty particles, those are the ether that's in the air. They're just always laying there. They're attached to whatever is in the air, the particles that are floating around the air. Primarily water molecules. Water molecules are extremely polar, H2O. That's what creates surface tension. You can float a paperclip on the surface of water, you know. It's because of the surface tension of the water. They're glued together.